and welcome to the School of Engineering and Computing Sciences 21st Century Leaders Lecture by entrepreneur, inventor, electrical engineer, physicist, and material scientist, cosmonaut, and space adventurer, Dr. Greg Olsen. And who best should introduce Dr. Olsen than NYIT President, Dr. Edward Giuliano. As president of New York Institute of Technology, Dr. Giuliano has championed innovation, technology, and opportunity to all, not just in the United States, but also globally through his speeches, conference presentations, and bold partnerships around the globe. During his presidency, NYIT has significantly increased the size and quality of its diverse student body of more than 15,000 students from all 50 US states and 106 countries, added more than 300 distinguished faculty and campuses in North America, the Middle East, China, and right here in Manhattan and on Long Island. Under Dr. Giuliano's leadership, NYIT embarked on a 2030 strategic plan that is designed to position the university as a model for a 21st century global university and a leader in student-centered, career-oriented education and applied research. Please join me in greeting NYIT President, Dr. Edward Giuliano.
Thank you and good evening and welcome to the auditorium for another stimulating evening, I hope. I'm very happy to be here with you, to hear from a man who actually, whose career not only took him around the metropolitan area, United States, around the world, but literally around the planet. Man who describes himself as a juvenile delinquent growing up in New Jersey, and he's going to take us through some of that life from there to here tonight. I don't know if you've ever been on Broadway performing before, but this is it on Broadway, another first. You know that I trust you know that the Obama administration is emphasizing Startup America, encouraging the idea that anyone can create something that may transform life as we now know it. The devices that no one ever thought of before that will provide consumers with new products, new ideas, new services, new jobs. Yes, jobs, perhaps the most important issue facing some of our students here in the audience today. And because you're here in the heart of New York, we should note that the city is a leader in everything from global commerce to finance to media, entertainment, education. You may know that Mayor Bloomberg has been leading an effort to make the city a center for engineering and technology. So while San Francisco and Boston initially emerged as the hot spots for new technology-based startups, New York has been a competitor, and Google recently expanded its operations on 8th Avenue, Foursquare, and Meetup are leading technology startups, and our own students are busily making up their new successes that we can talk about at future leadership discussions on Broadway. At NYIT, we offer quality education in the fields of engineering, science, and technology. We work with the community to give our students experiential learning. We look forward to expanding our hubs in technology, and that's why we're particularly honored to have tonight's speaker, Dr. Olsen, who founded his first, I don't know if it's his first, but founded his first Epitax in 1984, which is a fiber optic detector manufacturer. 8 years later, another company. I'm going to spare the details, but into that figures a South African winery, a Montana ranch. His investments as an angel investor certainly include startup companies ranging from iResponse Technologies, to electrical power conditioners. With all this going on, he somehow found the time, as I'm sure you know, to perform more than 150 orbits in space. It's about 4 million miles of weightless travel during his 10 days. And what I think I want to know, or we might want to know from Dr. Olsen is, did they serve honey roasted peanuts on the way up? And did they did they charge you the extra for the turkey sandwich? He is an entrepreneur of rare distinction, and I would ask you to join me in welcoming on behalf of the School of Engineering and Computing Science, tonight's speaker, Dr. Greg Olsen, space traveler, entrepreneur, and certainly no average guy. Thank you.
Thank you. Can you all hear me? Okay, that's a good start. You know, I've given this talk many times, and especially to younger students. I don't do the business part with the younger students, so you just cover the space. But I tell them the secret to life is 3 words, and that's just don't give up. And you know, that's true when you're 10 years old. It's true when you're 65 like me. Every setback I've ever had in my life that I came through, it wasn't because of money or connections or anything like that. It's because of perseverance and the fact that I didn't give up. So, you know, if you have to leave early, that's the essence of my talk. Don't give up. Really, I believe in it. This is a 2-part talk. First part is about business, how I started and sold a few high-tech companies. Then the second part is the fun stuff about my space trip. Another way of looking at it is, you know, how I made the money and then how I spent the money. But all right, we'll start off with the business end of it, and I'll give you a quick. I'll zoom through what you know we had in the introduction. I'm a local guy. I was born in Brooklyn, grew up in North Jersey. Was kind of a ne'er-do-well in high school, and you know that's really true. And I didn't have very good grades coming out of school. I barely got into the engineering department at Fairleigh Dickinson. But again, I struggled and I worked and, you know, got to where I was. So, you know, if you're in your classes now and you're worrying, geez, I'm not even sure I'm going to pass this, and, you know, I don't understand this stuff. I went to the guy twice and he explained it to me. I still don't understand it. I'm telling you, hang in there and don't give up, and you'll do all right, because I went through that and a lot of my peers did too. So anyway, you know, this is a capsule of my life. I've got a bunch of technical degrees, started 2 high-tech companies. I'm going to drill down and tell you more about it. Went to space in 2005 with the Russian Space Agency, and now I do what's called angel investing, or a form of venture capital. Now, after I got my technical degrees, I became a research scientist at RCA Laboratories, which was sort of a small version of Bell Labs. And pretty soon, nobody's even going to recognize these names. But, you know, 30, 40 years ago, these were the, you know, the be-all and end-all of electronics research. And I worked there for 11 years. I had no connection with business at all. My dad was an electrician. In fact, I worked through IBEW Local 3, 4 summers to help put myself through college, courtesy of my dad being a member. But anyway, in 1983, after 11 years of research at RCA, I decided, I just one day got the idea, hey, I think I can do this better, faster, and cheaper than these people at RCA. So I spun off and raised some venture capital, which wasn't easy. That's a whole story in itself. I remember the first investment bank I went to, and I said, hey, I want to borrow some money to start a company. And they said to me, can we look at your business plan? And I said, what's that? So that was how I found out what a business plan was. But I went home, you know, looked it up, did a second time, stumbled again, and you know, after 3 or 4 times, I was able to do it. But you know, all the time, I guess And people say, well, you sound fearless, and you just charge ahead and do something. I'm telling you, my guts shake as much as anybody, even today, when I do stuff. But I've just conditioned myself that, you know, no matter how scared I am, I just close your eyes and push ahead. And, you know, it's just worked very well for me. So Epitax was a high-tech company. We made, it's a semiconductor electronics for fiber optics companies. We made photo detectors, which are kind of like solar cells. They convert the pulses of light in the fiber optic system into electrical signals. Started in 1984. By 1985, you know, we had $5 million in revenues, and in 1990, we sold to a company called Nippon Sheet Glass for $12 million. So that was kind of a nice bump, you know, from 1.5 to 12. Most of you either weren't around or don't remember 1990, okay? But we were purchased by a Japanese company back then. And Japanese companies not only bought us, they bought Rockefeller Center over here, right? They bought Pebble Beach Golf Course out in California. 21 years ago, we all believed that Japan was going to rule the world economically, right? Because they were doing all this stuff, right? Didn't quite turn out that way. They kind of stalled in the 90s and are still struggling to a certain extent. Now, fast forward 21 years, and instead of Japan, substitute the words India and China. All right? Everyone thinks they're going to run away with the economy in the, you know, coming decades. Now, they're both here to stay, that's for sure. India and China are going to be economic powerhouses for the foreseeable future. But I wouldn't write the US off just yet, business-wise, based on this analogy. As a typical entrepreneur, after we sold the company, a year later, I left and started my second company. But as a little footnote, Epitax continued to grow, and by 1999, they had 1,000 employees, and during the dot-com boom, they sold for $400 million. Now, I wasn't around to collect that, but you know, at least I had a part in starting it up. So after I left Epitax, I went and started my second company, Sensors Unlimited. And that was a company that made infrared cameras that could see in the dark for night vision and other purposes like that. We were self-financed. They didn't have any venture capital. We used government contracts to kind of finance us. Anyone who's thinking of starting a small business, get to know what the letters SBIR stand for. It's Small Business Innovation Research. And it's a system where you can get up to $1 million of investment, not investment money, of basically a research contract where you don't have to pay the money back and you keep the patent rights. So now what better deal is that? And you know, it gives you the ability, before anyone else, bankers will invest in your company, it gives you the ability to start up and get things going. So in the beginning, we started as a research company in 1993, but by 6 years later, most of our business was commercial. We were selling these cameras into the market. And as fiber optics really kind of came to the forefront in 1998, 99, along with the whole dot-com, internet, telecom boom, our sales really started picking up. And you know, by 1990, we were 12 million. The year 2000, which was really crazy, again, I think most of you were around, but maybe you weren't as aware as us older folk was. It was just a crazy time. And even though our sales were only a little more than $20 million, we got acquired in the year 2000 for a value of $600 million, okay? It's like off the charts. 2.5 years later, market crashed. Everything went down. We bought ourselves back for $6 million, all right? Now, yeah, people think, boy, what a Sharpie. You know, this guy pulled the wool over their eyes. You know, he sells high and buys low. But let me tell you what the reality of that is. That $600 million, we weren't purchased for $600 million. We were purchased for 20 million shares of stock, of Finisar stock. Now, at the time of the purchase, that stock was worth $30 a share. So that's where you come up with the $600 million number. 2.5 years later, when the market crashed, that $30 a share had dropped to 50 cents a share. All right? So if you do the math, it's not such a bad deal going, buying yourself back for $6 million. Not such a bad deal for the parent company. In fact, we were losing money and had to invest more money afterwards to get the company going again. But we did, and by 2005, we'd become profitable again, and we sold ourselves for a second time to Goodrich Corporation for a sum of $60 million, this time in cash. But that was a more realistic figure than the wildly inflated dot-com times. So something you might notice, I've been doing this since 1984, now it's 2011, and business is very cyclical, up and down, employment's low, employment's high. It's easy to get money, very difficult to get money. I've kind of made a chart of this, which I'll get to you in a minute, but but I want to give you a little bit of history. Go back 11 years to March 2000. As I mentioned, it's crazy time. All right, the stock market was an all-time high. Everybody knew that stocks were worth more than cash. I mean, if I had a $30 stock certificate and $30 in cash 11 years ago, you wouldn't take the cash. You'd take the stock certificate because you knew that it was going to keep going up and up. Like, remember in real estate, 2007, you bought a house because you knew it was going up, up, up. Same thing with stocks. I mean, that's the way people felt. Times were crazy. Valuations were 10 times more. It's a good time to sell. It's just like real estate. All right? Fast forward 2.5 years, October 2002, everything is reversed. Market's down. Nobody wants stock. Everybody wants cash. Very difficult to raise money. Valuations have all dropped. That's a good time to buy. All right? And high-tech businesses are just like real estate if you follow the same principles. All right? Now is a good time. My daughter just bought a house in Florida, and she got a very good deal on it, and she wants to live there. And my advice to her was, yeah, go ahead. And she said, but everyone's saying that the real estate is lousy in Miami and so forth. I said, it is. I said, that's why it's a good time to buy. I said, just hang on to your house and you'll do very well. And same is true with high tech. Now, I mentioned this concept of leverage, how things go up and down, the availability of capital. 1 year it's great, 3 years later it's poor. People, 1 year are easy to find. 3 years later, especially in engineering, you can't get anybody. I have about 3 companies in power electronics and power engineering. We can't find engineers, so I'll put in a plug for them if anyone's looking for a job. So that goes up and down. But the thing that never changes is what I call leverage. And leverage is the ability to trade one thing off for another. When I started Sensors Unlimited in 1992, it was very difficult to raise money, all right? But it was kind of like a recession. There was high unemployment, so it's easy to find people, all right? And it's easy to get almost free rent. We needed millions of dollars of semiconductor equipment. We didn't have the money to afford it, but we were right next to Princeton University, which had this equipment. So we were able to kind of horse trade with them that we subcontracted our research contracts to them and helped them set up their equipment, and in return, they let us use the equipment. So, don't ever let money stand in your way. If you ever get to a point where you say, if I only had money, you're not thinking hard enough. There's usually almost always a way around that. So don't ever let that be a sticking point for you. One of the things that made Sensors Unlimited successful was we had a lot of partnerships. It's very difficult to operate in a vacuum. And this is true for all businesses, not just high tech. Very closely allied with Princeton University and Professor Steve Forrest. Sarnoff Corporation, which was RCA Labs, We interacted with them, shared research contracts with them, used their multi-million-dollar facility. You know, another thing I've learned, if you need something, just ask for it. And you'll be amazed how many times people will either say yes or I'll help you get it. That's another thing, like people let money stand in the way, they let that fear of being rejected. And don't let it. You'll be surprised how many times you won't get rejected, even though you're afraid you will. I'm also a huge believer in networking. That's one of the most important skills you can learn, even more than your engineering skills. I bet a lot of you belong to IEEE here. Even this, I was a student member in 1965. In fact, the reason I went to University of Virginia was because I went to an IEEE trade show at the New York Coliseum. How many of you know where the New York Coliseum was? All right, it was just right down the street where the Time Warner building is, right? There was a convention hall like the Javits Center. And University of Virginia had a little booth, and you know, I was going around getting those free pens and pocket protectors and so forth, and they recruited me. Any kind of professional organization, join it and become active in it. I'm still an active IEEE member. You know, I've been a chairman of conferences. I've been a committee chairman, and you know, it's just a great way, you know, of staying current in your field. Right? You know, how do you sell companies? And you know, I've done it about 3 times now. People sometimes come to me and say, "Hey, Greg, you know, you were good. You sold your company 3 times. Help me sell mine." You know, like I'm some kind of real estate agent. And the reality is you can't force the market. Now is not a particularly good time to sell high-tech companies. As you know, there are very few initial public offerings, you know, companies issuing stock to the public. The companies that are getting sold, they're getting sold for low prices. You just have to wait it out, and if you need to sell right now, you're going to take a big haircut, as they say. You know, you're going to sell for a very low price. It's all about timing, just like real estate. But the thing you can do when you start up a company is to be ready. Have a good management team in place. You know, if you want to present your company, don't present it like I'm doing now. You know, one person standing up there who's the center of the show and is telling you everything about the company. You need a team, people that, you know, engineering, sales, marketing, finance, and you know, if you have that team in place and you have a good presentation, you'll always come out all right. You'll always be able to sell yourself. And the other thing about selling companies, just like real estate, never hold out for the best price. If you get a good price, walk away a winner, right? And don't worry that your buddy's company sold for more money. And people do that with houses as well. When the house down the block sold for X dollars, you feel you've got to get X plus delta. And if you get X minus delta, you feel like you lose. When the reality is, if you got an excess money, you're a winner. So, you know, what did I learn from 25 years of startup companies? I'll go to my grave thinking that lean and mean is better. Right? I love companies that have a dingy exterior, that pay low rent, that pay low salaries, that don't have leased BMWs and Mercedes, and all the employees have stock options and lots of them. All right? If you go into a high-tech company, you're not looking for a pension at age 65. You're looking to cash out in your early 30s. Okay, so you know, that's why I like the whole idea of conserving the resources and putting it into the business. Another thing about startups, about management, right? Good managers work for their employees. It's not the other way around. If you have to tell your employees what to do, you're doing something wrong. I like to look for people that are better than me who will say, sorry, but I don't think that's right. I think we should do it this way. And you may have heard the expression, I'd rather you beg forgiveness than ask permission. You know, it's kind of in that same vein. A person with initiative is going to go out and maybe take a little bit of risk. And if he stumbles, we'll ask forgiveness rather than stand around looking for your permission for what to do. Lastly, people often say to me, since I've been doing this for 25 years, I bet you make fewer mistakes now because of what you've learned. And the reality is I probably make more mistakes now than I did in the beginning. But the difference is I deal with them quicker. All right? Most things in business, it's not like solving an equation that has an exact solution. Most business problems have transcendental or no solutions at all. And you just have to go with your gut. So don't be afraid to just pick a path. It's kind of like you're in the woods on a hike and you're not sure which way to go. Just, if you get to that position, take a path. It usually becomes clear if you're going wrong. And if you're going down and it doesn't feel right, stop and go back. And don't be afraid to say, I made a mistake. I'm going to fix it. So, what's business about? It's not about technology, and it's not about markets. It really is about people. And if you focus on good people and put all your efforts in there, you'll do very well in business. So that's pretty much the end of the business part. I'll just tell you what I'm doing now, which is this angel investing. I have an organization called GHO Ventures that puts up venture capital into other companies. A few of my companies, Princeton Power Systems, makes inverters for solar cells in the 100 to 500 kilowatt range that convert the direct current into alternating current at specified frequencies. I have a company, Achieve 3000, that it's an internet company that increases reading skills. Kids with poor reading ability, they can get 20 or 30% increases within a year. It's really caught on very well in the United States. I have a company, Common Ground, that chops up tires and puts them in road beds. Another one, Innovative Engineering, makes high-frequency power supplies for semiconductor fabrication. Innovative Photonics makes high-power lasers for cutting and welding. One of my most interesting companies is called Power Survey Corporation. They look for electrified objects in city streets. And they have a contract here in Manhattan. You'll often see their trucks from 9 p.m. to 6 a.m., white trucks going down the street with a flashing amber light. And they're looking for manhole covers, street lamps, fences, or anything else that could be electrified. You may remember about 7 or 8 years ago, a woman was electrocuted in the East Village here by only 58 volts. But it was kind of the perfect storm. It was a manhole, it was a utility cover where the neutral wire was contacting it. It was right after a snowstorm. They had salted it, so it's slushy with salt. And she had leather boots that were wet. It was just, everything was in the wrong direction for it, and very tragic. But anyway, they've used this technology. They basically developed a radio receiver tuned to 60 hertz that can detect a field of 1 volt at 30 feet. So, they've not only done very well in Manhattan, but they have about 5 or 6 other cities in the United States where, they look for safety things. Finally, I have a company, I got to spell this out, United Silicon Carbide International, that makes silicon carbide transistors. I think a lot of you know a little bit about semiconductors. Most, not just computer memories, but most transistors are made of silicon. Right? Silicon carbide has 10 times the breakdown voltage and also better thermal conductivity than copper, which means it can operate at much higher powers, much higher frequencies. And you may remember the size of a transformer is inversely proportional to the frequency. So if a transformer for 60 hertz is this big, if you work at 50,000 hertz, it can be this big. And obviously the Navy for electric ships, very interested in that. And we're developing what's called a solid-state transformer using silicon carbide. And we hope to, within the next 10 years, really make a contribution to the whole smart grid effort. All right, so that surely ends the business part. Now let's talk about space. And the most common question I get is, where'd you get the idea to go into space? All right? True story, I got it in Starbucks. Yeah. If you're ever looking for me, you can just check the nearest Starbucks. But since I'm based in Princeton, New Jersey, you can usually find me there with a big coffee and a newspaper in the morning. And in June 2003, I read about Space Adventures, the company that could take private citizens into space. As I'm reading it, it was just one of those wow moments. I said, yes, I want to do this. So I went home, I contacted Space Adventures. Next thing I know, I'm skipping over wildly here, but April 2004, I'm in training in Moscow, in Russia, to go up into space in October of 2004. Everything was happening fast and furiously, and oh boy, I'm going to go. Well, guess what? After 2.5 months, I had a medical exam. They found a little black spot on a lung x-ray. Whoosh, out the door I went, reject. Right? And it was a devastating experience for me. It was like, flunking out of college, getting fired from a job, that kind of thing. It really bummed out. So I went home. Turned out the black spot was harmless. It went away. Got a note from my doctor. Back to the Russians. I'm ready. Yet. All right? They didn't want me. Every month, I'd get more x-rays, notes from my doctors. Back to the Russians. Yet. They were afraid because, I had one lung ailment. I'd have another. 8 times I knocked on the door. 8 times they rejected me. The 9th time in May 2005, they let me back conditionally. As long as the black spot didn't come and you're perfectly healthy, you have a medical exam every day, all this stuff, we'll let you in conditionally. Yes, sir. I went in. I finished my training and I got to fly in October of 2005. But if I ever gave up, and believe me, after knocking on the door 8 times, you get pretty depressed about it. But I didn't give up, and I did get to fly in space. So just a few facts about the International Space Station. Many of you know Discovery landed for the final time today, right around noon. The International Space Station, you can read it up here, it's about 230 miles above the Earth, orbits every 90 minutes, makes 16 orbits a day. There's 2 ways of getting up there. One is the shuttle that launches and lands at Kennedy. The other way is the Russian Soyuz vehicle, which launches from Kazakhstan. I'm not going to embarrass you and ask you where Kazakhstan is, but it's in Central Asia, and it used to be part of the Soviet Union. Soyuz is kind of like the Apollo capsule. It goes up, and it comes down and lands by parachute instead of gliding like the shuttle. A little more information about the orbit. The orbit of the ISS is about 51 degrees to the equator. You can usually see both the shuttle you can see the ISS and the shuttle when it's flying once or twice a week. If you go on the NASA webpage, nasa.gov, and it'll put your city and state in, it'll tell you when it's visible at night. This is what the Soyuz looks like when it's being pulled out to the launch pad. Develops about 20 million horsepower peak. It's a 3-stage rocket, burns liquid oxygen and kerosene. I had about 30 friends and family that came over to watch my launch, and you can see the Russians are a bit more casual about their vehicle, and the shuttle, you can't get within miles of it before it launches. This is a picture of us walking to the launch pad. I'm on the left, our commander, Valery Tokarev, in the center, NASA astronaut Bill MacArthur on the right. You see those boxes we're holding are ventilating fans because the spacesuit is all rubberized to hold the air in, so it gets very hot inside. And anyone who's anywhere near my age, for me to salute a Russian general is just, unbelievable. It would almost be like dealing with Al-Qaeda today, but, that's how life is. This is what it looks like inside Soyuz, very cramped and crowded. It's the same array of me, Tokarev, and MacArthur. I'll share a secret with you. We had to stay in this position for 3 hours, no facility. We all wore Huggy diapers, and we all got to use them, because once you're strapped in, you can't move. So. Here's the launch, October 1st, 2005. We're sitting up top in that white section. It's as intense as it looks. You go from 0 to 17,000 miles an hour in about 10 minutes. All right? To do that, you have over 3 Gs of acceleration. We had over 3.5 times the force of gravity pushing back on us. Now, it only takes us 10 minutes to get into orbit, but you can't just go and crash into the International Space Station. We had to make 34 orbits so we could kind of slowly sneak up and get the exact height and velocity as the ISS in order for us to dock. So we spent 2 days orbiting inside of Soyuz. Here's what it looks like while we're orbiting, waiting to dock. Once you're in orbit and you leak check, you can open your visor, take the gloves off. I brought a video camera with me, which is still up on the station. I brought the little mini cassettes back, and that's some of the video that I'm going to show you today. Here's us coming up docking. Again, 17,000 miles an hour. Those are not wings, those are solar panels. Obviously, space has no air, so wings don't help you. We're inside the spherical habitat module, waiting for all the seals to be leak checked before we can go in. Here's the other side. 2 guys, they couldn't get the hatch open, so watch this, how they had to exert all their might to open the door. That's astronaut John Phillips in blue and Russian cosmonaut Sergei Krikalev in gray. They're real happy because they're going to get to go home in 8 days, now that their relief crew is here. That's a Navy bell that's up on the station. They always ring that anytime someone new comes up on the station. That's the NASA astronaut Bill MacArthur. Valery Tokarev. And here I come lugging my video camera. People ask me, what was the most fun thing you did up on the station? And it was just being weightless. I mean, just to be able to float for 10 days was an unbelievable feeling. And every time I woke up, I just pinched myself and I said, I can't believe this is real. We're all trained about, mass, inertia, and momentum, but you really get to experience it firsthand in a weightless environment.
The ISS.
This is looking back down on Earth.
Go off in a slightly different direction here.
Earth is a big blue sphere.
It's a nice picture of the world. Here's the Soyuz that I will return on. Top of the ourselves, we can see the arm, the robot arm. And another interesting view of the world.
During the day, which is about 45 minutes, if you were a space traveler, you would look and say, boy, what a nice, pretty blue sphere, and just keep on going, because there are no obvious signs of life while the sun is shining. And once you get on the other side and it's dark, then obviously you see lights. In fact, over the United States, you can see New York, Boston, Washington, all by the density of lights. But during the day, not so obvious. This shows how you drink water inside the ISS. I have a water fountain on my left hand. You can see from this why there are no showers and no sinks on the ISS. And this is how we eat in space. We either have canned goods or dehydrated foods. This is Miasa's meat mixed with rice and vegetables. It's good. Cosmonaut Sergei Krikalev, 803 days in space. We actually had internet service on the station, courtesy of the TDRS satellite.
It's kind of interesting. Just the pressure of his fingertips on the keyboard lifts him up to the ceiling. How about that? As he slowly disappears into all the storage containers.
It's much like neutral buoyancy for anyone that does scuba diving. You see, we don't wear shoes on the ISS because there's no weight. There's no need for shoes. This is just Newton's law of inertia. A body in motion tends to remain in motion. The hard part is stopping. Everybody wants to know, how do you go to the bathroom in space? So, these are the infamous toilets on the ISS that constantly break down. Now, the guy in the flowery shirt is astronaut John Phillips. He's been on board for 6 months. So he gets to show. Bill MacArthur's the new guy, so he gets to install.
NASA astronauts, you see them on TV? You want to know what space work is really like? Have a look. Yeah. Unstick any pipe with that. Yeah. And there's the completed job.
Yeah. That hose with the yellow funnel is the urinal. It's basically a vacuum cleaner hose. And anyone that likes procedures will love space. You know, turn on open switch S for motor M, open valve V, and all procedures. Both men and women use that urinal. Women have a custom cup designed to fit them. I'm not going to get too graphic about the space toilet, but I'll just call your attention to two things. One is that you notice it's smaller than a normal toilet. So you have to think about centering yourself. All right? And the other thing is gravity isn't helping you here. So when you get done, you want to slam that lid as soon as you can. And you know, the first time I had to use it, you just have a little curtain that you pull, and you're 3 feet away from all the other astronauts, and then they're just snickering and laughing because they know what you're going through. Someone asked me, how do you sleep in space? And the answer is any way you want. You know, horizontal, vertical, it's all the same. Up and down doesn't matter. What is important is that you tie yourself up. If you see those strings by my left elbow, or my right elbow, they're tying me to a wall. And if you didn't do that, you just float around and eventually knock your head on something. These are the types of cameras made by my company, Sensors Unlimited. Again, the near-infrared cameras for night vision. And this was video downlinked to our Princeton headquarters, so all the employees could see their cameras floating around.
Let me make one thing very clear. Check out.
Nothing inside. Recording.
These are the chips we made at Sensors Unlimited. These chips convert infrared light into a video signal.
All your handiwork.
If you remember your physics, this is a moment of inertia demonstration. A notebook rotates easily about 2 axes. Those are stable. Doesn't like to rotate about that axis. You can do this yourself.
Stable.
It's a stable axis.
Two of the axes are stable and one isn't, and I can't remember the reason for that.
Yeah. I had mechanics 40 years ago, but the answer is the Euler stability conditions. If you work out the differential equations of motions, it turns out that the 2 axes, the highest moment of inertia and the lowest moment of inertia are stable. The intermediate axis is unstable. It won't support stable oscillation. These next couple of view graphs just show how we undock from the station and come down. The Soyuz I docked in is still docked at the station. We're pulling back. Remember, this is all going on in a vacuum at over 17,000 miles an hour. So remember, space is a vacuum, but once we're braking, we're losing velocity, so we're dropping down towards Earth. Eventually, we're going to hit the atmosphere, and if you do that at 17,000 miles an hour, things are going to heat up to 1,000 degrees, thousands of degrees due to friction. So we jettison the habitat module, which has all the garbage in it, and also the engine. And we're in that descent module, which has a heat shield. Because when we hit the atmosphere, this is what happens. And that was the toughest part of the whole trip, was going through the atmosphere. There's a lot of shaking, rolling, flames, and you really have no control over it. So, but once we slow down enough, we deploy a parachute, and when we're about 1 meter off the ground, we fire retro rockets that enables us to land in the Kazakhstan desert. So we had a very good landing. There's a picture of my capsule, and they pulled us out within 10 minutes. And here's just some photos of our landing, someone opening my visor. The 3 of us, after you've been weightless for 10 days, your inner ear is unstable, so you feel dizzy. And that's why they treated us like medical patients here. Even though I could walk, someone was holding me up on each arm. So that's the end of the space part. I want to put in a little pitch for one of my companies, Princeton Power, which is looking for electrical engineers. This is my ranch out in Montana. I've got about a 4-kilowatt solar cell installation. Now, you know, the sun goes up and down. For 4 kilowatts peak, that's kind of like you're getting about 800 watts continuously all day long. So in order to save that energy, what I did in my basement is I have batteries. Now, that's about 16 kilowatt hours. Princeton Power installs big systems on the order of a megawatt hour. And to see one of the extreme examples, I also have a Tesla car, which many of you know is an all-electric car. But you know, it's just demonstrating this is the sort of thing that Princeton Power does. And my other company, United Silicon Carbide, hopes to make power transistors that will eventually go into electric vehicles. So I thank you very much for your attention, and if anybody wants to read more about all these journeys, I have a book on Amazon.com called By Any Means Necessary. Thank you very much. Glad to answer questions, or you call it.
Thank you for a fascinating talk. I have a question regarding the business portion of your talk, and I'm hoping we have at least a couple of dozen future entrepreneurs in the audience. So I know you mentioned that one should not let money get in their way, but I wanted to get your impression on something specific. In my involvement with the fabless semiconductor companies in the past 10 years, at least the conventional wisdom in the 2000s has been that with the semiconductor companies, because of the very high capital investments, you know, at least $2 million for one spin of silicon, 18 to 24 months of development, it's a lot easier to get angel or VC funding for purely software companies, you know, internet type of ventures, as opposed to going for the old-fashioned silicon. What is your impression on that, and do you agree with that statement?
I agree with it over a certain limited time. That stuff is very cyclical, okay? Software is hot, semiconductors are down, and it flips around, and vice versa. By the way, the semiconductor industry is probably one of the most extremely cyclical organizations that there is. Princeton Power and my other company, MLT Drives in South Africa, cannot get IGBTs, insulated gate bipolar transistors that are used for the power switches. It's like a 6 to 8 month backlog. And that also means you're going to pay a very high price. A year ago, you could get them at half the price. So there's a lesson in that. Next time, the price sooner or later is going to go down, and when you see that price drop, buy a whole bunch of them. But yeah, listen, I think if you're good at whatever you do, whether it's software, semiconductors, if you're good and execute well, you'll do well. And I don't think it's because you choose a certain discipline. It's because you execute well. That's my personal opinion. Yeah?
Next question. I'm from Kazakhstan, visiting scholar from Almaty. Probably my question doesn't concern this topic, but 2 years ago, the first time I made a presentation about rethinking Burat Kazakhstan at NYIT, this institute. Rethinking Burat Kazakhstan. I mean, there is about movie, Burat.
Yes, I've seen it.
Yeah, okay. So how did you find my country? According to this movie.
Oh,
because here is a lot of students, probably some of them they was on my presentation.
Borat was a very funny movie. Okay, so and I look at it that way. It was a successful movie. It was very funny. I've spent probably a couple of weeks total in Kazakhstan. I've been to, I believe, Baikonur, Arkalik, Almaty. I love the people, and yeah, I thought if you think Kazakhstan is what's in the movie, it's an exaggeration. Just as the scenes in Borat about the United States were also an exaggeration. So, but it's a great country. I loved it. Yes?
As a VC, if there is investors, what would you look for personally?
I look for people. I look for drive. I look for people. It says, if you don't give me that money, or if you don't give me what I want, I'm just going to go right around you and get it somewhere else. But I'm going to get there. It's drive. I don't look for business plans. We were talking earlier. Business plans and resumes are all so polished now. I don't put a whole lot of weight on them.
Thanks for the fascinating talk. Can you tell us a little bit more about SBIR? You had mentioned it.
Yes, Small Business Innovation Research. It's a system of funding that the federal government set up for small businesses. They set this money aside, and large companies over 500 employees, can't access this money. And I think there's a few $1 billion by now in it. And the way it works, you submit a proposal, and if they like it, and that means maybe now 1 out of 10 they select. But if you're selected, you'll get about $100,000 over 6 months. And then you can write a second proposal for a second phase, which you can get about $800,000 in the next phase. I might be a little off on the amounts, they're changing, but you can get from phase 1 to phase 2 almost $1 million over 2 years. So just put that into the web, sbir.com, and you'll see there's a solicitation about every 2 months.
You've basically done everything you wanted to do. You're a great success. You've been to space. For your future, what are your plans?
I'm not being facetious. My plan is to wake up tomorrow. I've never been a big strategizer, planner. Even though from a kid, I was always wowed about space. I also wanted to play first base for the Dodgers, and I never quite got there. It wasn't until I was in Starbucks and I read this story and I said, wow, I want to do that. I tend to get ideas on the fly. So, I just kind of want to stay healthy, and I know a year from now something else will come. By the way, this is networking right here. Or I gave a talk for the university and so forth, but I'm going to meet a lot of new people tonight. Just never know. This is how I get employees. This is how I get ideas.
Having been in space, what's your opinion of the future of the space program?
I think space, certainly commercial space, I'm really high on. I'm a big fan of Elon Musk. The guy not only invested in the Tesla, but he also was one of the founders of SpaceX, which has already orbited successfully. And I think if they do their next orbit successful, they'll be able to taxi up to the ISS. I don't see a lot of interest in the current not just the current administration. I don't mean the Obama administration. I mean both houses, Republicans, Democrats. I just don't see a lot of get up and go for space. I mean, it's the next frontier. I'm obviously a huge fan of it. I wish we'd have a vision. I don't care whether we go to the moon or Mars as much as let's pick a direction and go. And that part kind of saddens me. But commercial space, with Elon Musk and Richard Branson, all these things, that I have a lot of hope for.
You have an incredible success, and for the young people who are students, what do you suggest if they want to be entrepreneurs after their education or something like that? Mm-hmm. You want them to directly start any business or any kind of research work or something like that, or they want to get into the industry and get some experience or real-time things about the business, and after that they should be an entrepreneur? What's your suggestion?
Yeah. There's no formula for, I told you my story. That's the way I did it. One of the guy that runs Power Survey, who's one of the most successful people I've ever met in my life, has never been to college. But he just has, tremendous ability and intellect. So I don't think there's a formula for entrepreneurship. I always tell people, if you have any desire whatsoever for education. Do it while you're young. One of the best things I ever did I got my Ph.D. when I was 25 years old. The reason for that is I just started young. I started kindergarten at 4.5, graduated high school at 17, and I went straight. And I was lucky because I got it all done at a very young age. So there's nothing wrong with stopping, saying, all right, I got a BS degree, that's it, I'm going out. But if you have any inkling of getting more education, do it now. Don't think you're going to, it gets harder and harder if you wait.
What do you think about alternate sources of energy, and what's the scope of that?
Sure. Obviously, I've invested in, and I'm a great beneficiary of many forms of alternative energy. In my case, primarily solar and wind. And also, the state I live in, New Jersey, has great rebates or feed-in tariffs, depending on what you want to call them. So I'm a big fan of it. I don't see it as as a long-term solution. My opinion, and again, this is my personal opinion, I think nuclear is what's going to carry us over. I don't think alternative energies, the ones that we have right now, can base load us. The problem, solar varies. The sun's up, sun's down, there's nothing now. Wind, same thing. And people calculate these things, and they come up with figures on the order of the maximum, if you could do all you want. The maximum amount of solar and wind you could have is about 30%, because you always need what's called spinning reserve, just in case the wind doesn't blow and so forth, where you're going to get the power. So you need a generator spinning in the background, ready to come online if the clouds come over. So even though I'm a big fan and an investor in it, I don't see us in the near future going all alternative energy. I would like to see nuclear, and I would like to see long-term fusion come into play.
All right, sir. So you started off with a statement saying India and China are the coming up economies, but you still won't rule out the US. Being an entrepreneur, you obviously know what are the future scopes in US, and is there a good future scope as an entrepreneur in US or the coming up economies?
Absolutely. This is the thing. I travel a lot, and people there's a lot of things people like about the United States. Usually they don't like our government. Hey, but they love our food, they love rock and roll, all that other stuff. And even I haven't been to India, but I've been to China, and they love entrepreneurship in the United States. And I think we're probably the easiest country in the world that if you have the drive, you can start a business. I'd debate that with anyone.
Hi. So as graduating students, in the next year, or 2 or 3 years, would you have any suggestions for us as far as up-and-coming technologies that we can kind of divulge into or explore for ourselves?
Yeah. Obviously, the whole smart grid, for numerous reasons, I would say, take a good look, at least at the whole energy area, if you like it. But more than anything else, I would say follow your gut. If you want to don't choose a direction because someone tells you that's the right thing to do. That's the one. Do what you want to do, and even if it's not popular, if software is down now, but you love doing software, and I'm telling you, you'll do well at it. So that it's more important that you follow your own dreams than you follow the trends that's going on. But having said that, energy is a good field right now, and certainly for the next 5 years.
Yes. Why did you pick technology? What sparked your interest?
You mean from when I was a kid? Why did I go into technology? Oh,
yes.
My dad was an electrician. And when I was a kid, I used to follow him around with his toolbox, and he'd clip wires, and I used to save the excess wire, and I'd watch how he stripped the wire and, all this kind of stuff. you know, you're influenced by your surroundings. So I guess from day one, I was always with mechanical stuff. Something that most students don't have now that saddens me is like, my dad had a religion, and a religion is you never ever pay anybody to fix something. You always do it yourself. And whether it was the oil burner, the refrigerator, and I mean, I remember the birth of television, you know, where you get in there, and he had no training, but he kind of figured it out, how, you know, how the vertical deflection circuit worked and all that kind of stuff. So I guess from just having a father who was a technologist, I picked it up from there. I'm working on my grandsons now to do that.
Sorry, this is my second question. But I want to be like a green architect or a green engineer. Does that seem like a reliable field to go into? You're saying that energy is good for like possibly the next 5 years, but would that look like something that I should pursue for like my whole career?
Absolutely. I mean, assuming you have the interest in it, I would say definitely. You probably know about the LEEDS program where buildings now get certified. What's the cheapest form of energy? It's the energy that's not used, right? And, you know, so if a building is leaking out, you know, hundreds of kilowatt hours a day, and somebody can figure out a way to reduce that substantially, that's money in your pocket, and that's pollution that's never going to be produced. So I've taught a course on energy at Rider University for a couple of years, and I said, first and foremost, with all these alternate energy and nuclear, forget about it. Just cut down the energy use is the best thing, and you know, I think the architecture is a huge part of that. So you know, the Hearst building over here on 58th Street, they at one time, where I think they were the greenest building in Manhattan. I don't know if that's true anymore, but it's kind of nice that there's a competition that buildings kind of vie with each other to say, hey, we're the most energy efficient. So that's a real good field. Somebody in the back.
Hi, I'm Song Song. Do you have a plan to go to Mars?
Sorry?
Go to Mars?
Well, I would love to go to Mars. I mean, I figure I have another 3 years left. But I'll tell you, Space Adventures has a program where they will do one loop around the moon. You won't land. And this is using a Soyuz. What you'll do is you go up to the space station, and then they'll send up a second Soyuz as a booster. And you'll do one loop around the moon, and you use that gravity boost to come all the way back to Earth. It's a mere $100 million. Okay? So I guess I have to sell another company before I do it. But I would love to go to Mars if it's possible. One of the things we've learned from the ISS is, yes, indeed, it is possible for humans to stay weightless that long. And a lot of the things they're doing up on the ISS, food growth and recycling, you know, they're all drinking their urine up there now because there are too many people to bring up fresh water. Yeah.
Hi, can you little bit explain about the transistors? The transistors?
Yes.
Can you explain a little bit more about carbide transistors?
Oh, silicon carbide transistors. Sure. Again, silicon carbide is a compound. You know, silicon is a raw element. It's just a bunch of silicon atoms that come together in a diamond lattice. Let's say, you know, somewhat cubic in symmetry. Okay. Well, if you take every other silicon atom out of the lattice and put carbon in, you get a material called silicon carbide. Many of you may be familiar with it as a machine tool. You know, the oil rigs and so forth, the bits on the bottom are not steel, but they're materials like silicon carbide, tungsten carbide, and other very hard materials. The bond between silicon and carbon is much stronger than between silicon and silicon, so it wears better. The same properties give it a higher band gap and a higher breakdown voltage than silicon. All right, so a silicon carbide transistor can withstand a much higher voltage before it breaks down. So it's a better switch. It can handle more power. And those same properties mean it can switch faster. Also because it's a good thermal conductor, the heat goes away, so you can switch it faster and faster. So a silicon transistor can, let's say of a given power, can switch at maybe 10 kilohertz. Silicon carbide can go to 50, 60 kilohertz. And again, it makes those magnetic elements smaller and smaller. If you look up what the flux density is in a magnetic, it's inversely proportional to frequency. So it really means you can do the same power at much higher frequency. That's why silicon carbide. The downside is it's damn hard to make.
Last question.
What do you think about changing silicon for the calculations and computing and replacing it with optics, light?
Oh, sure. What do I think about using optics to as an optical computer instead of an electronic computer? Again, I guess I can be a little bit technical because you've probably had this. Fundamentally, the Nyquist limit. What's the ultimate switching frequency? And it's roughly half the carrier frequency, right? So optics has about 10,000 times higher frequency than an electronic signal. So in principle, optically, you can switch much faster. Now, there are technical reasons that limit that you can't get to the properties. But certainly, theoretically, it's a much faster computer, let's say, than electronically. And we will in time get to those things with integrated optics. All right, thank you.